Welcome to your lesson on Lewis structures and naming covalent compounds. Our first example today is going to be NF3. In order to name a covalent compound, we must use our prefixes. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa. These are the 6 prefixes that you need to know in order to name all of our covalent compounds. In this example, the first nitrogen is only 1, since there is no number attached to it. But as one of our special rules, we never start the first part of the name with mono. So instead, we don't use a prefix for it, and we just call it what the element is. We look on the periodic table, and it's called nitrogen. Now for the second part, we see that we have a number 3, so we're going to use the prefix tri. Since there's 3 fluorines, we use trifluoride. So we do change the ending to IDE at the end in order to name the last part. So when we put it all together, NF3 becomes nitrogen trifluoride, the tri for the 3 of the fluorines. And we do have the IDE ending. Alright, now we want to draw the Lewis dot structure for NF3. We first begin by doing the Lewis dots for nitrogen and one of the fluorines. Okay, and we compare the dots. If you do the dots correctly, they should look very similar to this. Nitrogen has a pair of dots up here, which we call lone pair electrons, and then single dots on 3 of its sides, which are known as the bonding electrons. Fluorine has 1, 2, 3 sets of lone pair electrons and 1 bonding electron. Now, the reason we're comparing them is because we need to figure out which one will be in the center. Because nitrogen has 3 places in which it can bond to, it can bond in more locations than fluorine, we're going to put nitrogen in the center. Now, we have 2 more fluorines that we need to put on our structure. We've only used 1 right now. So I'm going to put the other 2 fluorines around the other single electrons that are the bonding locations for nitrogen. So it will look like this. Now, our job is to find our bonding locations for fluorine and nitrogen and pair up the dots. We're doing this because we need to complete the octet for those elements. Fluorine right now has 7 valence electrons. It needs 1 more. So it's going to share this electron with the nitrogen and they will form a bond. Okay? Now nitrogen is going to do this with each of the fluorines so that nitrogen can complete its octet and fluorine can complete its octet. Alright, so now that we found all the bonding dots, bonding electrons, and paired them up between the nitrogen and the fluorine, everything will have its octet. But this isn't our final structure. We have to redraw this as a bond instead of a circle with the dots. So when we redraw our structure, it's going to look like this. Notice that this is no longer a circle. Instead, it's a line representing a bond between your fluorine and your nitrogen. So those 2 electrons, 1 from your nitrogen and 1 from your fluorine that were originally there, now became a bond. So that bond represents 2 electrons. Also notice that we still have all the lone pairs in all the locations that they were originally. We don't take them off. If you take them off, you won't have your octet. So we can double check that this structure is correct by counting our octet. Nitrogen has 1, 2, and remember each bond is 2 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, so nitrogen has its octet. And fluorine has 1, 2, 3, 4, 5, 6, 7, 8. So fluorine also has its octet. And each fluorine is very similar, so they all have their octet. That is your completed Lewis dot structure for NF3 or nitrogen trifluoride. Okay, let's do another example. This time, we're going to do the compound CO2. Okay. Now, we want to name this first, so we look at our prefixes again. Again, we're starting off with one element at the beginning, which is carbon, so we're not going to start with mono. Instead, we're just going to call that carbon. The second one is 2, so we use the prefix di, and we put it in front of the name for oxygen. So instead of it being dioxygen, we name it dioxide. So the whole name for this compound becomes carbon dioxide. Right? Now we want to finish off and do a Lewis dot structure. So the very first thing we have to do is compare two of the elements, carbon and oxygen. We have to compare them. So to do that, we draw their Lewis dot structures. Carbon has its 4 valence electrons. Oxygen has its 6. If you do them correctly, they're going to look very similar like this. Now, we compare how many bonding electrons they have. Carbon has 1, 2, 3, 4 bonding electrons, but oxygen only has 1, 2. Because of that, we're going to put carbon in the center. Now we need to use our other oxygen that we haven't used yet, and we're going to put it on the other side of carbon, so it looks like this. Now that we have all the elements that we need for the structure, I'm going to start by pairing up the bonding electrons from this oxygen to the carbon. So I'm going to start with this bonding electron, and I'm going to pair it up with this top bonding electron to the carbon. So there's a bond. Notice that you still have another bonding electron on this oxygen. So we're going to stay with this oxygen and go to another one for the carbon. All the bonding electrons on your oxygen are completed, so we're going to move on to this oxygen. This oxygen has 2 as well, so we're going to do something very similar. We're going to bond these electrons, and we're going to bond these electrons. Okay. Now, let's count real quick, just so we see how many bonds we have. Notice that this oxygen and this carbon have 1, 2 bonds. And then this carbon and oxygen also have 1, 2 bonds. So we're going to call this a double bond with this oxygen and carbon, and this is a double bond with our carbon and oxygen. So when we redraw our final structure with the bonds, it's going to look like this. Okay? Notice that those 2 bonds get redrawn like lines, and they kind of look like an equal sign. And you have it between this oxygen and carbon and this oxygen and carbon. Now let's count our octet to make sure our structure is complete. Oxygen has 1, 2, 3, 4. Remember, bonds are worth 2 each. So that's 1, 2, 3, 4, 5, 6, 7, 8. Carbon has 2, 4, 6, 8 within the bonds, so it has its octet. And oxygen over here is the same as this, so it also has its octet. This is your completed Lewis dot structure for this molecule, CO2, which is also called carbon dioxide.